Hey everyone! So today we're diving into a really cool new study that might just break the frustrating cycle of recurring infections. You know the drill, right? For so many people, the standard treatment just feels like a temporary fix. But what if the real solution wasn't about, just destroying the bad bacteria, but actually about rebuilding our body's own natural defenses? So, what is at the heart of this problem? I mean, why do some infections, like bacterial vaginosis or BV, just keep coming back? You treat it, it goes away, and then boom, it's back again. Well, it turns out the answer might actually be in the very treatment we're using to fight them. All right, here's our game plan for today. We're going to start with the big problem, that whole revolving door of current treatments. Then we'll introduce the hero of our story, a probiotic designed to bring things back into balance. We'll get into how scientists actually designed a clever way to deliver it, and of course, how they tested it. And you're going to love this next part. We'll look at a super high-tech way they came up with to fingerprint the final product to make sure it's the real deal. And finally, we'll wrap up by talking about what this all could mean for the future of treatment. Sound good? Let's jump in. Okay, first up, the vaginosis recurrence problem. Yeah, before we can really appreciate the new solution, we've got to understand the frustrating cycle that these researchers were so determined to break. So bacterial vaginosis, or BV, is super common. But here's the thing, it's often misunderstood, misdiagnosed, and honestly, a lot of people just don't talk about it. And for those who do get treatment, the number one complaint is almost always the same thing. It just keeps coming back. The standard approach we have right now, it's just not cutting it for a long-term fix. And this right here gets to the absolute heart of the problem. Think about standard antibiotics like a weed killer that, well, it also kills all the beautiful flowers in your garden. I mean, sure, it gets the job done, it wipes out the bad infection-causing bacteria, but the big unintended consequence, it also wipes out all the good protective bacteria. So you're left with this clean slate, yeah, but it's a slate that is completely vulnerable to reinfection. And that's what kicks off that vicious cycle all over again. Okay, so if the old way is basically scorching the earth, this new approach is all about reseeding the garden. And this, my friends, is where probiotics enter the picture. You see, a healthy vaginal microbiome is this really delicate ecosystem. It's just like a garden. When it's thriving, it's dominated by a group of good bacteria called lactobacilli. And what they do is create this acidic environment that naturally keeps the harmful bacteria that cause BV in check. So the goal isn't just to wipe everything out, right? The goal is to restore that natural protective balance. And this is the hero of our story today, Lactiplantibacillus pentosus, KCA1. Now, this isn't just any old probiotic you'd find on a shelf. It's a very specific strain that was originally isolated from a healthy woman, and it's known to be especially good at bringing back that protective acidic environment. This is the ally that researchers picked to go to battle against BV. So, you've got your hero bacteria, awesome, but now, how do you actually get it to the front lines where it needs to be? The next big challenge was a super practical one, designing a really effective delivery system for these live probiotics. What the researchers came up with is actually, surprisingly straightforward. They created a base using glycerol and gelatin, melted it down, and then they carefully mixed in a massive dose. We're talking 100 million colony-forming units, which is just a way to measure the amount of live, viable bacteria of our hero probiotic. Then they just poured this mixture into some molds. Simple, elegant, and super precise. And the final product was really designed with the user in mind. It's smooth, soft, and odorless. And get this, even the bullet shape was chosen on purpose, based on earlier studies showing that it's the shape women actually prefer. I mean, that shows some real thought went into the whole user experience, which is great to see. Okay, so they've created what seems like the perfect delivery vehicle. But now comes the most important part of all. They have to prove that it actually works the way it's supposed to. The researchers basically had to answer three critical questions. First, does the probiotic even stay alive in the suppository over time? Is it stable? Second, does the suppository dissolve properly once it's used? And third, maybe most importantly, does that process actually release the live bacteria so they can get to work? And the results? Well, for the dissolution test, it was a huge yes. The suppositories completely dissolved in less than 37 minutes. That's well within the 60-minute requirement for these kinds of products. So what does that mean? It means the delivery system is fast and efficient. It's releasing its precious cargo right on schedule. Okay, but what about stability? I mean, do the probiotics survive? Well, over a 3-month test, while stored in a fridge, the probiotics stayed alive and kicking. Now, there was a slight drop-off over time, which is pretty normal, but the bacterial count stayed really high. This was the proof they needed that the formulation was a success. It could keep the probiotics viable and ready to go. All right, now this is where we get to the second major innovation in this study, because it's not just about creating a great product, it's also about creating a modern, super efficient way to check its quality. So the researchers used a technique called FTIR spectroscopy. The absolute best way to think about this is like a molecular fingerprint scanner. Seriously, it shines infrared light on a sample and then reads back the unique signature of the molecules inside. It's incredibly fast, it's cost-effective, and it doesn't even damage the sample. It's pretty amazing tech. But here was the big challenge. Could they use this scanner to find the specific, one-of-a-kind fingerprint of the pentosus KCA1 probiotic, even when it's all mixed in with the gelatin and glycerol and everything else in the suppository? It's kind of like trying to find one specific person's signature on a document that's been signed by dozens of other people. And they did it. They succeeded. Now, the text here on the slide looks super technical, I know, but the takeaway is actually really simple. They found it. They were able to pinpoint the exact spectral region, that's the specific part of the infrared light reading, that acts as the unique molecular fingerprint for our hero probiotic, pentosus KCA1. And for quality control, this is a huge deal. It gives them a fast, reliable way to prove that the active ingredient is actually in the final product. Okay, so let's pull all of this together. What are the big takeaways from this really impressive piece of research? Basically, this study really delivered 2 major achievements. First, they created a promising new probiotic delivery system that is stable, it's effective, and it's user-friendly. And second, they proved that a high-tech tool like FTIR spectroscopy can be used as a practical, cost-effective way to identify microorganisms in pharmaceutical products. This could make producing and verifying these kinds of advanced probiotics so much easier and more reliable in the future. Which brings us to this final thought. We've just seen a treatment that's designed not just to fight an infection, but to actually restore a healthy ecosystem. And we've seen a brand new way to guarantee that treatment is exactly what it claims to be. So the big question is, could this powerful combination of targeted probiotics and high-tech quality control finally change how we treat recurring infections for good? Based on this research, the future is looking incredibly promising.